So, hey guys, welcome back to the series named In the Search of Shooting a Cat, in which we are talking about quantum mechanics in a form of a story by which you can easily understand what I need to say and how this happened. So, be with me in today's story named Quantum Math, in which we cover the topic named as a quantum math because the classical math is very different from the quantum maths and how we will tell you in the form of story in this topic. Okay, so be with me. I hope you enjoy. So let's start the story. All start. Okay. Imagine a world where number define logic, where probabilities control destiny, and where the very fabric of reality is written in an equation so bizarre that they challenge our deepest understanding of universe or our understanding existence. Welcome to the world of quantum math, where the universe is not what it seems. It's all began in the early 20th century when scientists tried to understand the smallest building block of reality. What they found was very terrifying. Particles behave like waves behave like particles, and probabilities rule over certainties. Classical physics, our proud, well structured castle of knowledge, collapsed into a swirling sea of paradox. So now begin to the chapter second. In this series, we are covering different chapters by you can easily understand and make an image of a triangle like a circle by which you can easily put the topics by topic and put in a mind. So going to the chapter second name Schrodinger's equation, the language of quantum reality. The equation suggested that a particle, say an electron, was not a tiny ball spinning around an atom's nucleus. As Bohr had thought, it excited in a cloud of probabilities, an eternal mist of potential state. The equation looked harmless, but its implication was nightmarish. If a particle had a wave function that spread across space, then where exactly was the particle? Nowhere, everywhere. Okay, this means reality wasn't a solid, well defined structure, it was a mathematical ghost. And thus, Schrodinger's cat was born, and the chapter third, the madness of probabilities. Quantum mechanics doesn't deal in absolutes, unlike classical physics, where an object has definite position and velocity. Quantum objects excited in a haze of probabilities. We know quantum mechanics from starting. What we observe is what we get. What we don't observe doesn't exist in the quantum reality. This is the best described by Bohr's rule, named after Max Born, which tells us that the probability of finding a particle is at a certain place is given by the square of its wavelength, of its wave function. This equation means that before we measure a particle, it's not a, it's not in any single place. It's all in all possible places at once. Only when we observe it does it choose a location. This raises a terrifying question. Does reality exist before we look at it? All quantum mechanics as a base on it, like it's a base. Is a reality exist when we are not observing it or it not? So, here's the chapter 4's come. Heisenberg's uncertainty, the edge of knowledge. Okay, so here, if quantum mechanics wasn't disturbing enough, Warner husband Warner Heisenberg arrived with a relation even more unsettling. The more precisely we measure a particle's position, the less we know about its momentum. हाँ अंदर रखता हूँ अभी बस रखता हूँ Just listen to me. The more precise we measure a particle's position, the less we know about its momentum. So this means we cannot define the particle's position and momentum at the same time. This means there is a limit to what we can know. No matter how advanced our technology gets, no matter how powerful our microscope become, nature will always keep some secrets hidden from us. It's as if the universe is whispering, there are things you will never mean to know. This says by Heisenberg. So at this, we are jumping to this chapter 5, the quantum jump, when reality blinks. Listen to me. In the quantum world, particle doesn't move smoothly like planets around the sun. Instead, they jump from one place to another as an instant like teleportation, like from this place to this place in a single blink or less than that. Okay? It is this is described by quantum superposition and quantum tunneling. We are working on it, like some says we can by using quantum mechanics. We can also make a quantum tunnel by we can easily teleport one thing to another place or galaxies in just a blink of eye. Okay? So, mathematical phenomena where particles vanish from one spot and reappear somewhere else without traveling the distance in between. This is the secret behind modern technology like quantum computing and even nuclear fusion. But there's more. Chapter 6, the area mathematics of entanglement. Einstein called it spooky action at a distance. Two particles, light year apart, light year apart. We also say like one galaxy and another galaxy. The one particle is here, the one particle is here. So somehow remain connected. We can also say that one atom and one atom are connected in a single element and we apart it, but it already connected. Like it's still connected to each other by an invisible line or invisible force. They are still light year apart. Okay. So change one and then other change intestinally faster than the speed of light. So here they broke the rule of reality. Like the Einstein equation where we said that no one can go faster than the speed of light. And how this happened? Listen to me. Okay? This means the universe is more deeply interconnected than an ever imagined. Reality is not local. And here's the chapter 7, the ending come, the quantum future. An array as quantum math is it is the foundation of a modern world. Every smartphone, every laser, every GPS system relies on quantum physics. How? But the future holds even greater mysteries. First, quantum computer that can break encryptions in seconds. Quantum teleportation, which could one day lead to instant space travel. The search of quantum theory of gravity, which might unlock the deepest secrets of the universe. And perhaps, just perhaps, the answer lie not in the universe, but the equations themselves. Note the line. The answers lie not in the universe itself, but on the equation themselves. The universe is written in number, but are we ready to read them? So that's about the quantum max. I hope you enjoy. We will meet in the next amazing topic in a quantum world and quantum math or another topic. So be with me in the series. I hope you enjoy.